Okay, and we are moving on to the cylinder head. Now, unfortunately, the ring file I ordered didn't arrive in time, so I can't go onto the pistons. We're gonna dig into there, a lot of metallurgy, the ARP studs and everything. We're still gonna do the head gasket assembly as well as the torquing on the head. We're gonna do the head studs as well. But for now, I think the segment we're gonna focus on the cylinder head. So I haven't actually pulled this head apart since I got it back from the engineers, because it started turning like 3 months. Like, listen guys, just do the block, I'll do the head myself. So yeah, let's see how bad it is. I might have to end up taking it back to them, being like, nah man, this thing's not straight, gotta fix it. But we'll see. So they were supposed to skim the head or the block, so they they decked the block and did the bore but didn't touch the head. So yeah, and it's going to take too long to do that. So yeah, this is as I got it off the car. The car was a non-runner, so we're probably going to do some analysis on this head as well, look at things going through and stuff you got to look out for when doing this. So let me get my tools here quickly, and then we'll get on that. Okay, so first things we got to do is we got to get this head open, see what it looks like on the inside. I mean, we've got debris everywhere, so just, you cannot assemble this in this state. You got crap everywhere. So let's get this cover off and have a look at the inside, how things are looking. I'm probably going to be replacing the head studs on these, even though they already had the head studs, ARP 2000s. They just don't seem up to the task. Righto. I've got a little container on the side here just to put all my stuff in. We're going to clean it properly. Now, first thing that hits me is like, look at all that sealant on there. This is crazy. Look at that. So this tells me that this gasket cover had issues with sealing. Like, now see, this is what I was kind of talking about on the other one when we didn't record. So when you put a bit of sealant on, when we did the halve assembly, there was only a tiny bead running around, not like this. This is like a massive coliseum of sealant coliseum, and it's just if you're running this level of stuff on here, probably it's not good, because that like look at these things, it's protruding there. That will break off. Look how easily that comes off. That goes down into your sump, gets sucked up in an oil pump, suddenly you run main bearings and you don't know why. So that it happens, guys, it happens. Yeah, so anyway, let's not dwell on that. I do think I had these loose. Okay, so we're going to take the cams out now, because we're basically going to tear the head down to the basics and see, how these are just not tight. I didn't put them on any tension when they went in storage. So normally when I put a head in storage, put on like a cardboard kind of effect, something that won't like damage the sealing surface. I remove all the tension from the cams, so the cams are loose, and then the cover goes on top, hand tighten the bolts in, and that basically is how I put it in storage. So we'll see, this video might get long, there's a lot of things you've got to get through. So yeah, this is the camshaft. Oh, that doesn't look good. Now, I've been wanting to replace cams on this, but I didn't want to do that until I had a look at the tune. I'll show you guys why that is in a bit, because there's just massive carbon buildup on this thing, which tells me that this guy did run some kind of tune on his vehicle, and I reckon that's probably the thing that caused a lot of troubles, because there's so much carbon buildup. When we had like the old pistons out before I cleaned them and everything, there was like massive carbon buildup inside the rings. The rings were stuck inside the pistons. There's just carbon buildup everywhere. Yeah, okay, so with these journals, same as with the crankshafts, we want to keep our journals in line. We want to make sure that we don't swap them around. To make it easy for us, they've got, if you guys can see that, little arrows pointing I1 pointing inwards. Oh, how did I miss that? Yeah, these cams are stuffed. Yeah, that's all starvation. These cams are stuffed. Yeah, anyway, so that's unfortunate. But yeah, so anyway, carrying on with that, we're just going to tear down. So we're basically removing these caps, I1, I2 pointing inwards, I3 and I4 pointing inwards. We have our cradle here. I think it's called a cradle. Take that off. And yeah, take this side off as well. So it does appear that these cams are not suitable for our applications. We've got a lot of expensive parts going in here, and we're not exactly going to be cutting it short on that, which means I'll probably need a set of lifters, which means probably go to the valves, because the profiles are going to be different on the cams. Yeah, so this just got I really don't know how I didn't notice that before. I mean, that's pretty obvious. But anyway, let me get this off and I can get you guys some good views on that. So top side, E1 pointing inwards, E2 pointing inwards. I'll probably do that nice little trick I do with things. So E3 inwards, and then this side inwards. So yeah, so this is an indication of, you know, given the state of the stuff we took off and everything. Oh, and keep in mind, I don't know if you guys can, let me just take it off the stand here quickly. Something you guys really got to see up close. Sorry for the shaky footage. Do I have a pointy stick? I'll use this bolt. So notice how the hole here is bigger than the hole there. That's because this one has dowels in, so that'll be I3. See, you got the little locating dowels there at the bottom of the bolts. Now compare it to the other one. Never put things open like that on top of an engine, because they'll fall in. So you can see the difference, how that one has the dowel on there and this one doesn't. So keeping our order in place, I2, I3, and yeah, let's get this back on the stand. So we're just still tearing the head down, doing sorry about that, putting on the stand, getting analysis on like what exactly happened with this thing. So here are some pretty good marks you can look out for. So taking this out now, when you are working with camshafts, don't do that, especially with the BMWs and the Mercedes. They normally have like a valve system or a vacuum pump or something in the back that goes into the back of the cam. I have seen some Hondas with it. I think it was a Honda. And then if you lift it up, you break the thing clean off. Yeah, so let's have a look at this camshaft. Clear that up. Pulleys look alright. Now, I did know that these journals were not that great. However, I didn't know they were this bad. Chip on my, no, contamination again. That was going to go down the sump. So yeah, let's get some nice shots on this. So look at that wear and tear. Can you focus? Not professionally. Oh, look at that. Yeah, so you can clearly see these lines running there. Now, possibly you can just polish them up. There's actually no ridge on there. There's a bit of a ridge there. So this one's pretty bad, this journal there. I don't know how to make the camera focus on just one thing. So here you can see you got nothing there, and look how the wear then comes in there. Look at the shiny surface. So I am thinking, so notice how this the coloration here is similar to what the light is on here. Similar to the coloration of what the bearings were. And get that thing to focus. Yeah, there we go. Focus on that. So look, the coloration here is similar to what we had on the main bearings, and you've got this bright shiny metal. So that tells me if there's a coating on here, that coating probably came off now. So I mean, look at this. Look at this one, for example. This is a perfect example. So look how super shiny polished that is. Look how dull and brown this one is. So these cams clearly have got damage on them. You could possibly just polish them up, but then it's going to take me another 4 months of engineering to do that. So what we could do to do that, actually, I'll probably have to build a rig for this, so we can actually salvage these. That'll be a nice video to do. Yeah, so I'm not happy to put these things back in the engine. I mean, you can just look at that ridging over there. That's just, if you see that, not good. Okay, so yeah, that's a bit of a blow. It was bad, but not was that bad. And up here we can have a look. Let's clean this one up as well. Actually, at this stage, it might just be cheaper to get a whole new cylinder head. At least then I won't have to wait 4 months for engineering. Yeah, and here we see the same thing. So this tells me that this engine had some kind of problems with oil starvation. Where is it? Oh, there, that's the edge there. You can clearly see that on the camera. Can you clearly see that on the camera? Yeah, you can clearly see it on the camera. Look at that. Look at that journal there. Not good. This side as well. Front side here. Got a lot of markings, scoring, and that. So, yeah, I'm not going to assemble this head then. Today we're just going to focus on getting it down, tear it down, clean it up. So what I'm going to do now is clear up these edges here, because now my concern is, well, if the cams look like that, what does my mating surface look like? Because I'll be like, no, that's a problem, because if we have got a mating surface issue here, we might have to scrap the head, and I'm seeing it right there. So let's get some clean things on here. Oh, this guy's actually worked on the head before. This is interesting. Yeah, that's why you never really rush through things. These bearings looking pretty okay. So with this one, on this one here, with a cam cradle on this side here, you have a bearing there. See a little bearing there, similar to what we had with the what do you call it? The main bearings on the engine. You guys can see that over there, and yeah, it points it out. So yeah, so you guys are seeing like a real-time failure analysis here. I was kind of do a whole thing of like, oh, I assemble the head, we can take the valves out, reseat the valves. Now that I might have to potentially replace the cylinder head, it's not on the table anymore. So this might be interesting tile. I don't even know what I would call it. I can't call this cylinder head assembly because we're not going to be assembling it. Yeah, so let's have a look at that. So cylinder head, we've got overhead cam set up. We've got these bucket shims. See if I can get one of these out so I can show you guys how it looks. I don't know where to put my magnet is. Let's choose this random cylinder here. Right, there we go. So on your, oh, this is very nice. Let's clean this up much so I can show you guys this. So notice here you've got your valve and retainer coming in there, nice polished in there, and have a look at this little cup here. So this here is your cam follower, yeah, also known as a bucket shim, and they have quite a bit of wear on them, but they have a thickness. So when you are adjusting your valve clearances on this one, your thickness of these would be different. So normally you would change, so you see it got a little number on the inside there, 3, focus, there we go, 3.345. so that is the thickness of this one, the rated thickness. Also look at the discoloration again. See that little polished surface there and the dark one in there, so that indicates wear. We're not seeing any scoring, so deep cuts in it. If you run our fingernail over it, we're not picking up any resistances. I'm just going to put that back before I confuse it. So you've got your intake side and you've got your exhaust side on that. And when you take these ones out, you would normally take them out in order. So you'd have cylinder 1, cylinder 2, cylinder 3, and 4, and you would lay them out. See if I can move this a bit. Yeah, I can. And then you would lay them out, kind of like this, in the sequence that you take them out. Basically, as they stand here, it just makes it so much easier when you reassemble. Take that out in a bit. They are still moving relatively freely. So this here, why it's not coming out, is called a hydrolock. So the oil on the inside basically stops air from coming in. So liquid is not compressible. So it kind of holds, it sucks it in place. Basically, it's like pulling a vacuum on that. So I'll get that in a bit. Normally you use like some special tool to get these out. Just 2 there. So you're always following your shape on what you're doing. really should brought my magnet for this. Now, one thing to keep in mind when doing shims, sometimes they have a little plate there. So this inside section there, the little shiny bit there, which you would see there, is actually a little tiny metal disc. And you can change your metal discs on your shim spacers instead of replacing the entire follower. I think, well, what's this engine I worked on that had such a nice, I think it was a B18 or something. Can't remember, but basically on the valve it had like a big open disc with, oh, I think it was a Hilux, I think it was, yeah. And it's got like a big metal plate there, which you can just swap out the plate thicknesses, which is great. And all that, yeah. I'm a little bit rusty, I haven't done this in a while, so it's taking a bit long. But yeah, so that's basically how we take it out, and you keep them in pairs of 2. Let's see if that's in shot. Yeah, pairs of 2, you keep them here, just you get this guy out. Now, also you want to look at how easily the follower comes out. Does it slip? Does it glide? Does it catch anything? Is it chunky? Is there debris in it? I had it now a second ago. Yeah, well, she's not coming out now. Don't want to waste everyone's time on that, because they are smooth and slippery and that. So it's always the one, like, you get everyone out except the one that you're working on. All the others are like effortless. I mean, it is the one guy that just doesn't want to work with you. So look in there. See, you even got debris inside there. So if you look in here, focus camera, good, like a big zoom in there. See all those little particles floating around there, little dots and everything? That's debris. That's dirt. That's stuff that's been floating around the engine. I haven't taken these off yet. This has been there since the car was, well, since the car stopped running, basically. So yeah, not good hygiene. Car probably was not serviced either. So we can look at our cup sizes here. That is, I like to just clean them all, you know. Of course, the hygiene, because now we got all this debris in there, anything. So we're probably going to dunk this entire head in a parts washer. Yes, 3.315. That one, 3.300. C, there's like that little letters on them, yeah. So I see, put a white code. 330. 3. Yeah, these things are dirty on the inside. That's 330 as well. And seeing that we kind of, normally you keep these in order. You don't want them to get swapped around and that, but seeing that we're probably going to be replacing camshafts, which will require us to replace followers as well. 345, 343. So those two are actually the same. And then, yeah, I probably should call this video failure analysis. 2.3, 3.375. So yeah, not going to be sealing valves today. That's what I was looking for. So all that, we'll never get to play with the other tools. But yeah, so failure analysis on the head is then. Sensors, we want to take them off because they can break easily. If this sensor breaks off, that's plastic, that's metal. If that thing breaks off, oh, you can have a bad day. So let's see, that should be 10. Let's get our trusty old ratchet in and just take them out. Back here. So yeah, it looks like it's going to be a while before I'm driving it. That's fine, gives the other parts time to arrive whenever they decide to get here. One there. It's like here. A little bit over tightened, but okay. Let me take these sensors out and then I'll zoom out here a bit. Go back to normal zoom. And then we will continue with that shortly. Okay, so that is the sensors removed. So this one here, this is our exhaust cam variable valve solenoid. Let's look at the coloration of that. It's pitch black. You can just see the difference in there. If I wipe it off, So the oil that's been running in this vehicle has not been changed in a long time. Yeah, so if you do take these ones out here, no, actually no, this is the front one. Yeah, it was there. Yeah, so we're going to be replacing these O-rings. O-rings are on the wrong there. They're the ones that tend to leak, so we're going to be getting new ones in them. I don't know if they're in our kit actually. Yeah, and obviously, so what we want to do is we want to look for contaminants on the inside of there. Can I adjust this thing to see better? It doesn't look like it wants to. Yeah, so we got to check if we've got contaminants inside there, and we want to replace the O-rings. When you take this one out, you do want to use that there to use a little bit of leverage. Obviously you want to pull it out directly, you don't want to use force. Never push on this connector here with anything. It's plastic, it will break. You're not gonna. And then I'm pretty sure this solenoid here is a relatively expensive one, and we've got two of them. So yeah, so looking at the rear one for the exhaust side, yeah, and then you can see there now she's relatively clean. I'm surprised about that. I was expecting to see debris on the inside on that. The lighting quality is pretty bad in the video actually. Sorry about that, guys. Not really sure why that is. I'm not a videographer, I fix machines. Yeah, so she's pretty alright actually, looking good. Figured maybe replace these, but they're looking good. So we're going to test them and just see, you know, how they operate at a later stage. Okay, so with that done, we can flip the head. Oh, we still got to take out the exhaust sides here. Let's do that quickly. Alright, so we got them out here, and you can just look at all the contaminants just sitting on the side of that thing. Just look at all the contaminants sitting on there. That just, you know, that's going to get inside your oil feeds and everything. Could have been prevented by an oil change. So I'm assuming that a lot of the damage we're seeing here is actually related to just poor maintenance. That's what I'm thinking of. I mean, like, look at the dirt on the inside of that thing. So and that's been there for a while. That doesn't just get there. That's just not proper hygiene. If you can call hygiene, engine hygiene. I don't know if that's a thing. But yeah, so we got those here, there. Exhausts, intakes. We're already gonna redo all of the valve seats anyway. So I'm not really too worried about the order. But normally you want to keep them in order, keep them the way that they should be, keep them in position. I want to show you guys this before we turn the head over. So I don't know if the camera's going to show that. Let's have a look. Let's prop this up somewhere so it's like at an angle. Oh yeah, I reckon that's pretty good. So interesting thing here I want to show. Let's see if I hold it like this. Put that there. Yeah, that should prop her up nicely. Take it off the stand here. I want to show you guys some things here. So this is the main reason why I didn't purchase cams on this bolt, even though we are going to do it eventually. Let's get some focus going here, maybe get some zoom on there. Let's look at, probably, let me just get something to point with. So the camera doesn't really show it, but if you could look there, see these massive flakes of carbon. They're like leaves coming off there. I don't know if you guys, I can see it in daylight, but the camera just doesn't show it. I just need like a bit more bright. There we go. Right there. Look at all that carbon buildup on the inside here. They're coming off in the leaves. So that makes me think that this tune on this car is way too rich for what the guy's been running with. Obviously I don't have the best camera in the world, but yeah, let's look there. Yeah, this entire area there is a entire flake of carbon buildup there. The same stuff we saw when we come on camera, all that stuff there. I'll get it back on the stand. Yeah, sorry about that, guys, just the camera does shake a bit, but you have all of these carbon buildups here, and like it was in the rings, it's in the exhaust, it's on the block, it's just everywhere. And I'm reckoning that the tune on this car is just nowhere near what it should be. But we will obviously check that when we get it going. But I'm gonna, you could like chisel off. You could like start a quarry of carbon here, like a carbon quarry. If I have to like clean up all the carbon here, the ocean temperatures will rise by like 4 degrees. Yeah, so this head's not looking in too good of a shape at this stage. So let's get it flipped over and look at the things. So far we've determined that the look at that surface. Oh my goodness. So far we've determined the camshafts are worn. We have excessive buildup in our systems of carbon, debris, all kinds of other lovely things which you normally don't agree with. So interesting thing I want to point out here, look how shiny the surfaces here are from just off the assembly point. So this engine was actually recently rebuilt. You can clearly see, I mean, some of these edges here that are protruding like that there. So you're going to look at this edge. So that's normally like I think it's a service limit block, so that's how far you can skim the head down. Though don't quote me on that, I could be wrong. But basically when you start hitting that block, you've kind of reached the limit of what the service engine's cylinder head can reach. So yeah, someone's already been working on this for a few times, and you can see that this engine has not been running a very long time, which again strengthens the assumption, that is an assumption, it's not a fact, that the tune might be incorrect. And here we can see our exhaust valves on the side there, and here are bigger intake valves on the inside. So yeah, let's get this cleaned up a bit. Let me have a look. Now, resurfacing of cylinder heads, very controversial topic. When resurfacing cylinder head, it is best to take it to a machine shop. There are some guys with cast iron that says, no, we just use an angle grinder and it's fine. On aluminium, you cannot do that. The yield of, okay, well, we probably got to get into metallurgy for that, but for example, steel has a yield strength of about 340 megapascals, if I remember correctly, carbon steel. So what does yield mean? Yield means the point where it starts to deform, break, or that. Hardness is also a lot harder. Aluminium is 80. 80, let's zoom out a bit here. Here we go. You can see a bit better. So 80 megapascals versus 340. This is a much softer metal. It is more ductile. So in metallurgy, you have the trade-off between strength, hardness and ductility. The more hard something is, the more brittle it is. That's like your cast irons, things like that. Not that cast iron is really hard, but it's a brittle metal due to the higher carbon content. And aluminium is a softer metal, so it's a lot more tensile. So tensile means basically stretching it. Malleability means compression it. So tensile strength means the strength of, if you were to pull it, is a lot lower. It's a softer metal, you can easily machine it. If I probably dig my fingernail in here, I could probably scratch the surface. I mean, you can probably see those scratches there now. It's a soft metal. So if I were to take this here and I drag it across here, I would definitely damage the surface. If I do the same thing with the camshaft, it's not even going to make a mark. See there? It doesn't affect it because this is a much harder metal. Oh yeah, let's knock the cams off the table. Sensors. That's a brilliant idea. That's a safe way to do it. Sensor there, that's the intake side. So all about hardness. So you cannot just grind this over concrete or put it on a belt sander. Now Garage 54 did do a thing with a made machine. That is the backyard hack of kind of doing it. Pretty good, but the problem that I have with that is that they're applying a motion which over a surface can wear this down if this surface is not properly balanced. Now you have more metal on this side than you do here, so your weight's automatically more heavier that side. So if you carry on with that, you're going to get a skew head, not a good surface. The most accurate way to do it is to take it to a machine shop. Now I have measured the flatness of this head, it did check out. And then let's quickly get the things I need for this. Right, so this is gonna freak a few people out. when working on a head and you want to get all these debris off, you can use a scraper. Personally, what I use is a brace for it, orbital sander with a 600 grit sandpaper on that. People might be like, oh no, you can't, it's gonna miss it. This is for indicative purposes only. It's not to resurface the head, it's to remove material. So this is so soft that I can put my hand on it and it's not going to cause any damage. This is not going to take down metal. So it's only to get these debris off the front end, top end here. And you want to have a flat surface that you want to align it with. So again, 600 grit. You want to keep it light, and that'll be an indication as well of your surface on the cylinder head. Now, there's a high chance that this head might be completely scrapped, but yeah, we'll see how that goes. So notice immediately we have even there, a little bit of extra here, somewhere on the edge there. Now these are debris, so I have to take that off by hand manually. So let's get our scraper and do that. So there's too much gasket buildup on it, and you cannot get a proper reading from that. So very gently, very lightly take off small edges of the head. I don't want to compromise the surface. All those debris. Now I'm not worried about it falling into the pot because we can do a really deep clean on this one. So this is excess gasket material, probably coolant buildup. You can see from the orange there, probably a potential coolant buildup. Gently work it through over the edge there. Long, smooth streaks, what you want to do. You want to get all that gasket material off. Look how much is coming off. So that sanding disc we've used is even lighter on the material than what a blade is. So look how much more the blade's taking off that the sanding disc did not. And that's the thing, like, you've got to understand that you want to take off the softer material, but the harder material needs to remain untouched, undamaged. Yeah, let's go with undamaged. So yeah, just clearing it down slowly, applying light pressure. You don't want to actually dig it, because with this blade, if I basically, where's the plate? Let's do this. If I do that, I've made a groove there. Now it's catching on there, and you could very easily do that. So easiest way to do this, just send it to the machine shop. They'll get it up for you nicely. They'll probably clean it for you nicely as well, and you won't have to worry about all of these problems. And I've got a feeling that this head needs a lot more work than what I initially thought it did. But hey, that's how it is. That's what you get when you get a non-running Evo. You get what you pay for. If it's cheap for a reason. So see here, I'm getting the blades catching on the edges, which tells me I might have some deformation, which means not in the shape that it should be. Gently gonna move that down. See there, so the blade is actually taking down a little bit of an edge, but it's in the combustion chamber, so I'm not too concerned about that. We want to change the angle. Again, guys, this is real-time stuff. I don't edit my things. I don't get a script with fancy, oh no, this is how it goes. Because if you're doing this yourself, this is what you can expect. Unexpected problems, misaligned surfaces, incorrect assumptions. Anything can happen. Every 5-minute job is just one broken bolt away from a 10-day ordeal. And yeah, man, I'm not happy with the surface. This is not running the way I want it to. I'll probably have to send this back to the machine shop. So, is there a way you can probably do it at home? Yes. I suppose there are many ways. But the thing is, what are you going for? You're going for accuracy. If this is just a Corolla, well, Corolla's really reliable, so they're pretty good. Or just an everyday passenger vehicle. You know, we're not going to be running high boost. We're not going to be doing weird things, because the biggest problem is we need this thing to seal. If we got all these weird little things all over the place, it's not going to seal. I mean, I'm already questioning if that water port is even separate from the other one. So yeah, let's see what it looks like now. We're taking some things off. And at the end there, you've got to keep in mind, like, what exactly you're trying to achieve here. What exactly is your goal? Are you trying to just have a car to get to work and back? Then you can probably put it on, because the gasket material will probably take up that edging. That's what a gasket does. It picks up the open edges. So if you also look at these guys that are grinding these things with like angle grinders to get their smoothness that they need, so they can basically put the head back on, they're running like 2 or 3 millimeter thick gaskets. We're running an MSL, so that's really small. It's really tiny. It's really, you don't have that much room for error. You know, like, I'm thinking that maybe the 600 is too hard for this as well, because you're seeing almost like a shiny surface. Not exactly what you want to see. You want to have like a nice smooth uniform. So you can just take it up to another grade. I've pretty much used up that disc, so I'm going to the next one for that. So let me change my sanding pads quickly. Righto, so carrying on with this. The motion you want to follow with this method, keep in mind, it is a cleaning method, not a machining method. You want to do left to right, right to left, and just keep on maintaining the pattern. Light pressure that you're applying, let the tool do the work. And you can already see here that there are some deformations coming through for this. Keep in mind 600 grit on this one that you're working, you know, not even going to damage your hand if you work on it. So that gives you an idea of like how lightly we are working on this one here. And we've got to keep in mind our surface finish needs to remain smooth as well. And any imperfection that you have, kind of like paintwork, if you're doing bodywork or stuff like that, you would kind of see what's going on here, where the higher edges get polished off and your lower edges have clear dark indications on them. And looking at this here, analyzing the dark patterns here and there, that's a coolant gallery, that's an oil drain. So you can see there's almost a line going there, and these ones they're basically on the same thing. So if I were to leave this as is, that's probably gonna blow through. So not so much look at that big dark coloration there. So you can kind of see it's an indentation there. Here you have the same thing. So obviously, being it's a very light grain, so let me just work on that, and then we can do some proper analysis. Alright guys, clean up a bit. So here is the situation where we're currently sitting at. So let's analyze this quickly. So we've basically just slid it across the surface, clean off the debris, and you probably can see these little arches running across. That is the machining marks of the previous time the head was worked on. Now relatively she does look pretty good in that. However, I want to point out some things here. So notice at your coolant ports, you've got this dark patches here. So this has to do with aluminium's high thermal expansion rate, where as you start the engine it gets really hot. And also notice that is on the exhaust side, where the intake side is running a lot cooler. So this is basically how the metal moves around. It gives you really the ability to visualize it instead of just shimming everything off. On the colder ends you have a much more uniform surface. Now look how in this area there we don't really have any of the lines or the dark patches. So this to me tells me it's a high spot. So all the dark spots are low spot. This is also a common tactic used by panel beaters and bodywork people. They put on like a dark layer and they sand the top off, and the dark spots that remain are the low spots which you need to fill up. Similar to when they machine it, they would put like an engineering glue on it, and they would skim it over and then look where the high spots are and then do another pass. So in this case, let's see if we've got a good ring seal around there and another one around there. So I'm sure that our cylinders will seal. However, if you follow these dark areas here, they pretty much almost overlap with our weld channel. So our bolt basically goes through there, so our stud's going to be there. This is going to be a coolant, that's probably going to be oil. And am I talking nonsense now? This is going to be your oil drain. So oil drain over here, oil, 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 oil. And I'm not at ease with this. So looking with these coolant ports, there's clearly an indentation over there. There's almost like an imprint almost there. So that tells me that this head, although it is probably within spec, does need to be resurfaced. So that's to say, we use a light sanding disc. We're not taking away any of the material. I mean, you can even still see the machining marks on it here. That's how little we actually affected the surface. It's only for indicative purposes. Again, you're not going to resurface the head this way. Why is that? Because as you're moving your hand out here, it's not uniform. You are creating small imperfections over the surface of the metal, and when you're clamping this down, it's going to make a difference. If you are running a 5mm thick paper gasket, I don't know what, some heavy diesel engine, this is good to go. You can probably send it like that, because your gasket's going to take up all of these imperfections. Now let me get the head gasket for this so I can show you guys what we're talking about. Okay, so here's our gasket that we're going to be using, right? This is metal. Metal ain't going to fit in there. It ain't going to take up that space. It's not a squishable. It's going to seal. Yeah, it's definitely going to seal. But the thing is, not in these ports. If you put a flat surface on that and it's metal, it doesn't have the ductility to take up that space. Now, if you're just going to be running to work and back, you know, you're not really worried. It's just doing a project car, maybe your first build. Probably this is good to go, because you can look at your areas around your bores and they're completely round, so you know you're gonna get a good seal around there. But when you start running in high horsepower applications, you need to start thinking about how this head's going to move. Is the clamping load going to keep it down? When it lifts in the boost, is that not going to run all the way to your oil channels? You know, things like that, stuff you got to look at. Which I don't think. See, that area there tells me it's pretty close, so I wouldn't really probably worry too much about that. But it is possible. I can't. It's a non-zero chance that under high boost applications, this part there might leak into there, or that part there might blow through on it. I mean, look how close that is to the edge there compared to this distance. That's the lift we're working with. I mean, we've done all this trouble now to get all these components and gonna get new cams and everything just to basically screw it up and then to have to redo all this again. Not worth it, guys. So I'm gonna have to stop the video here. There's just too many things that needs to be done to this head, so I'll label this as failure analysis. Even though the head's probably functional, but for what we want to do, it ain't gonna work. I'm not happy with this. We probably could salvage it, but at this point it's like, you could, but if it doesn't work out, you're taking a risk. You're guessing now. You're estimating, and you can't really do it. Okay, well, suppose we could just check the straightness of it first. Let's see if we can do, maybe just check the cylinder head warpage, but then again we did touch it down, so it's probably going to show a 0. But let's look at that quickly. Okay, so we're just quickly going to check the surface now. This is not the best straight edge. It's kind of twisted, so rulers are not the best things to use for straight edges. They just not up for the task. You want to have like a nice beam with a sharpened edge on that, which will not deform. Sadly, this thing was packed in a weird position and now it's not straight anymore, but I'm just going to demonstrate to you the case. So you probably want to use a specially designed straight edge for that. You can purchase them. They're pretty good and straight. So what you want to do with this, so we have our service limits here. That is 0.04 millimeters or 0.05 inches. And this is the service limit. So 0.05 millimeters. If this goes through, we know that we've exceeded our service limit on that. So let's just have a look here on that. And as you can see, look at that massive gap that's there, here and there. It's pretty good on this side there. That's our service limit. It's not supposed to go in there. So like I said, this is our high spot because we've got no dark colorations there. And that's just not going in. I don't know how I managed to pass this the first time, but yeah, so keeping our edge straight, as straightest that we can. But you can see there's clearly, even with that, there's clearly a play in that area, so that exceeds our service limit right there. So when you check your head, you want to do it 1, 2, 3, 4, 5, and then you can probably go across if you want to, but we normally do cross, bottom, middle, top. That's how we normally check it. So in these areas, look there how we're going through, and then here all the way. Actually, that could probably just be because we have a bad straight edge. Like I said, you know, this is not exactly the correct straight edge to use, but you kind of get the idea. I mean, if that is perfectly square there, and you can slip this thing in through underneath there. I mean, it's paper thin, but I mean, like look there, like I could probably get like an even bigger piece underneath there. Here as well, same thing. From this high spot to that high spot, I mean, I can like, that's probably like 10 moles. What am I saying? 10 moles, tenth of a mole that's going through there. I mean, look how easy that is there. Even the flex of the ruler, that's just not gonna work. So, like I say, it all comes down to your application, because in our application, this just is not gonna work. It's not gonna hold boost. It's not gonna perform as it should. So this clearly needs to get sent back to the engineering, and we need to get that resurfaced. There is, at this stage, no reliable way that I've found to accurately do it at home. You can do it, like I say, it depends on applications and how much tolerance you're willing to live with. But in my personal opinion, for what I want to do, it's not going to work. Send it in, get it resurfaced, and that's the thing. So that basically bottoms out the whole thing. We got to get our cams polished up. We got to get our cylinder head resurfaced. I'm probably going to replace these valves because it looks like this thing has been running way too hot, which could have damaged your valves as well. Those will be thermal, what's the correct word? Thermal fatigue, where the valves get treated in high heat temperatures, and then when the car overheats or something like that, it would almost anneal the valve, because really hot turbocharger sitting right here at the back doing its thing. So unfortunately, guys, I have to end it there. We're not going to be able to finish up this head today. I wasn't impression we could have, but that's why I always double check things. Sometimes you're like, yeah, it's fine, you know, measure twice, cut once. I would say measure thrice and cut once. But yeah, so even though you have all these nice smooth surfaces there, we clearly have indentations, lower surfaces here that need to receive attention, because it's just not gonna work in our layer application. So if you had like a cosmetic gasket and you're going on a cast iron block, happy day, she will take it. The gasket will definitely fill up those areas, but according to the service manual, we have a 0.05 millimeter service limit on this. That's how you check your warpage. Yeah, guys, that concludes it. I'm gonna wrap it up here, package this up, and then get it back. Obviously, you know, there's not much more we can do on this build until we get our parts back and our head back and everything. I'll probably ask them to have this deep cleaned as well. So yeah, we'll see where we go from there, and then take it from there. Okay, guys, have a good one. Catch you on the next one.